Thomas Kane. I'm doing my project on video. So here's my first one. It's linear. So for my linear one, I did beryllium hydride, which is BeH2. And I used gummies as my atoms. So here are those. Here's my picture. And this is the Lewis dot diagram. And the bond angle is 180 degrees. And the number of shared electron pairs is 2, and the number of lone electron pairs is 0. And beryllium hydride is nonpolar, so which is the same for all linear. And that is my linear. For my trigonoplanar molecule, I did boron trifluoride, which is BF3, and this is my creation that I made. This is the Lewis dot diagram. The bond angle is 120 degrees. The number of shared electron pairs is 3, and the number of lone electron pairs is 0. And it is a nonpolar molecule. And these are my dipole arrows. Tetrahedral molecule, I did methane, which is CH4. And this is what it looks like. And this is the Lewis dot diagram with 4 shared electron pairs. The bond angle is 109.5 degrees. As I said, there are 4 shared electron pairs and there are 0 lone electron pairs. And methane is nonpolar, shown by the dipole arrows here. So for my tetrahedral, I did methane. For my trigonal pyramidal molecule, I did ammonia, which is NH3. And this is my picture. It's important to see that it is not directly on the ground. It is slightly angled upward. Instead of this, it's up like this. The Lewis dot diagram looks like this. There's 1 lone pair on it. The bond angle is 107 degrees. So this is 107 degrees. The number of shared electron pairs is 3. And the number of lone electron pairs is 1. And for trigonal pyramidal, it is polar. So ammonia is polar. And these are the dipole arrows to show that. And this is my trigonal pyramidal ammonia. My bent molecule, I did water, which is H2O. And this is the picture. As you see, it's not like linear because these parts are bent. The Lewis dot diagram looks like this. The bond angle is 104.5 degrees, and the number of shared electron pairs is 2, while the number of lone electron pairs is also 2. And water is polar, and these are the dipole arrows. And so for my bent, I did water, H2O. So for the VSEPR theory, the concept is it's a set of rules that a chemist or anybody is able to predict the shape of the molecule. So it's pretty much based on the premise that the groups of electrons that are surrounding the central atom repel each other and they go as far away as they can from each other. And so these groups of electrons can participate in a single, double, or triple bond, and that would be the shared electron pairs, or they could be lone electron pairs where they don't participate in any bond. You're also able to determine the number of electron pairs that are around a central atom by making a Lewis dot diagram and looking at the bonds and the lone pairs that are attached to the central atom. So the electron density of a polar bond accumulates towards one end of the bond, which causes the end to carry a slightly negative charge and the other end a slightly positive charge that's away from the polar side. So there's a series of steps that you're able to take to figure out whether a molecule is polar. And one of these is that by using the molecular geometry, you can determine if any of the dipole movements cancel out. So the arrows, if they cancel out, if they do, and there's any resulting dipole, it indicates that it's a polar molecule. Practically, and pretty much, polar covalent bonding is a type of chemical bond when a pair of electrons is unequally shared between the two atoms. So there's not an equal amount of electrons between the central atom and the paired atom. Opposing to polar covalent bonds, non-polar covalent bonds are a type of chemical bond when the two atoms share a pair of electrons with each other. So pretty much non-polar is usually when there's no leftover lone pairs and the electronegativities equal out. So all in all, non-polar molecules are pretty much, sorry, when they share give electrons, if the electrons are shared equally and there is no resulting positive or negative charge, then the molecule is nonpolar.